Is concurrency in Go actually as simple as people make it out to be? Well, in Go, we can freely fork off a child branch of execution, in this case an anonymous function that prints data, to be run concurrently with its parent, in this case the main function. This is done by simply using the Go keyword, which is Go's foundational concurrency primitive. Note that the anonymous function that prints the data is invoked here. This creates two separate branches of execution, the main function, which in itself is a Goroutine, and the child Goroutine. But we aren't limited to two. Using the Go keyword, we can continue to fork off child branches of execution, making the Go keyword a very powerful tool. Now, the Go keyword helps us to achieve the top portion of Go's model of concurrency, which is known as the fork-join model. But what about the bottom portion, or the join portion? The join point is the point at which our concurrent branches of execution join back together. Since our current code does not implement the join functionality, our three branches of execution will run independently of one another and they are in no way synchronized. So as you can imagine, if we were actually to run this code, you'd notice that our main function would finish its execution before our child functions can print their data. So how do we implement the join point? Well, we can do that by using another one of Go's concurrency primitives, channels. Channels allow these independent branches of execution to communicate with one another. This means that we can create a communication channel between our parent Goroutine and its children. Now, instead of directly printing the data, let's put it onto the channel that's linked to the main function. We can then have the parent Goroutine or the main function await communication from its children before completing its execution by reading from the communication channel that we created above and assigning the resulting data to a variable. And yes, this means that this line of code here will block until data is received from the channel and assigned to the variable. What you'll notice here is that the main function will finish executing immediately after receiving and printing the data from only one of the Goroutines, since we are only reading from the channel once and then printing the value. To get the data from both child Goroutines, we'd actually need to read from the channel twice. But at this point, you're probably wondering, isn't there a more intuitive way to receive all of the data from the channel in a loop or something? Well, there is, which brings us to Go's next concurrency primitive. We can use what is known as a wait group from Go's standard library to wait for our Goroutines to complete their work. So let's create a wait group and add the value 2 to its counter to indicate that we will wait for 2 Goroutines. Then, within each Goroutine, we'll defer a call to waitGroup.done until after the function's execution. Each call to waitGroup.done will subtract 1 from the counter of 2 that we added to the wait group initially. And when that counter reaches 0, the program knows that it no longer needs to wait for any Goroutines. So now let's call waitGroup.wait, which will do exactly that. Then once the wait is over, we can close the channel. Finally, we can iterate through and print the results. Now, in the real world, it's not always so buttery smooth. It's possible to have a case where a Goroutine is running too long, for example. In that case, our entire program is blocked by one Goroutine. So what if we wanted to gracefully handle terminating the program in this case? Well, this is where the final Go concurrency primitive, the select statement, comes in handy. Before we get into the explanation, for those of you that are interested in becoming an indispensable member of a Golang team, I have a full course available on microservice architectures using the Go programming language, where we'll build out an entire microservice architecture. And following the completion of that course, you'll also get career coaching from me personally. So if that's something that you're interested in, the link will be in the description below. Given two cases where in each case we're receiving a message from a separate channel, the select statement will block until it receives a message from one of these channels. But in this current code, only the code from the case that finishes first will be executed. If the messages from both channels are received at the same time, only one will be executed at random. So as you can imagine, this has limited usefulness since in this code, anything from the other channel is disregarded. That is, unless we wrap this select statement in a for statement, creating a for select loop. This makes our program a long-lived program which will receive and handle messages from both channels without terminating. And there you have it, Go's concurrency primitives. If you found this video helpful, don't forget to leave a like, and I'll see you in the next one.